So today you are going to go through the last, level of solving equations that have square roots in them. But before we get there, we have to go back a little bit and remind ourselves of something. How do we solve quadratic equations? We spent quite a bit of time on this. So just a quick reminder of factoring and then a quick reminder of quadratic formula at the bottom. Please join me on page 9 of your notes. Let's write some things down so that we can figure this stuff out. First thing you have to remember when we're factoring or using quadratic formula, we need to make sure the equation is set equal to 0. So for this first example on page 9, I'm going to subtract 2x and 15 from both sides. That will make the right side 0. And on the left, we have x squared minus 2x minus 15. Factoring, a little x thing that we've drawn. We're searching for two numbers that multiply to negative 15, our c value. And when we add them, we're looking for negative 2, our b value. If you can think of those numbers yourself, great. If not, those numbers that are going to multiply to negative 15, it's going to be in the 3 and 5 realm. And then when we add those to get to negative 2, 5 has to be negative. Because negative 5 times 3 is negative 15. Sorry about that. That didn't look very good. And negative 5 plus 3 is negative 2. Those are our two numbers. So the one thing that didn't go well on our last test was you have to remember those are not our answers. Those are the numbers we write our factored form in. Those are not our solutions. Remember, to get our solutions, we have to take our individual factors, our x minus 5 and our x plus 3, and we have to set each of those equal to 0, and we have to solve. In this case, our two solutions are x equals 5 and x equals negative 3. So that's a little reminder of factoring. Quadratic formula, at the top of this page, I just scrolled down on my notes, but you have the piece of paper in front of you that has the quadratic formula in the top right corner. Just remember, you got to make sure that you have one side equal to 0. We're going to subtract 1. Our a value is in front of the x squared, so that's 2. Our b value is in front of the x, so that's 4. And our c value is our constant, and that's negative 1 this time. If you didn't move the 1 over, you were going to say that c is 1. And unfortunately, that would get you the wrong answer. Now you're going to plug everything into quadratic formula. You're going to do the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all over 2 divided by a. So our b value is 4, so that's going to go in those first two spots. Our a value is 2, that's going to go behind the 4 in the equation, and it's going to go in the bottom as well. And finally, our c value, which is negative 1, is going to go behind that first top a value. Simplifying, I know you want to use your calculator. It's a little bit easier to do a little bit of this yourself. 4 squared is 16. Negative 4 times 2 times negative 1 is positive 8. And then the bottom 2 times 2 is 4. So it's negative 4 plus or minus the square root of 24 over 4. We hopefully know that square root of 24 does not have a nice solution, so we'd have to round. And if you use your calculator for this part, which you would need to use your calculator if you were going to round this, I think you get about 0.225, and you get about negative 2.225. Remember, to get the two answers, you do one with the plus, and then to get the other answer, you do one with the minus. So there is our reminder to get to our last type of solving equations with square roots in them. We're on level 3. So you'll notice that our steps are basically the same. Isolate the square root on one side. We only have one square root. What's going to make this problem tricky is now we have a variable on the other side that isn't in the square root. So our first step of isolating the square root is done in this case. We don't have to do anything. Just like our second step has always been, we're now going to square both sides. This is where we finally get a little bit of something different. We have an x squared in our equation now. And how do we solve equations that have x squareds in them and other variables floating around too? That's where you got to use factoring or quadratic formula. A lot of the times we should be able to factor, so you'll see me factor quite a bit. I'm going to do 3 problems here. I'm going to finish this one and 2 more, and you'll see I'm going to factor for 2 of them, use quadratic formula for 1 of them. So look at our step 3, solve for x. Since there's an x squared, you'll have to factor, use quadratic formula. Our thing to remember is make sure it's set equal to 0. So for this problem that we're going to work on right now, I'm going to subtract x and 12 over to the left side so that the x squared is positive. That's going to make it easier to factor for me. When I'm trying to factor, remember I'm looking at the c value, 2 numbers that multiply that. I'm looking at the b value, which, be careful here, it's -1. Trying to get 2 numbers that will multiply to -12, add to -1. If you want to think about those numbers yourself, you can pause it and try to get to the end of this problem. Otherwise, I'm going to keep going here. Those 2 numbers are -4 and 3, because -4 times 3 is -12, -4 plus 3 is -1. And remember that those are the numbers we factor with. Those are not the answers. Remember, we have to take our factors, set them equal to 0, and solve. So we get x equals 4 and x equals -3. Now, remember, you have to check answers. We have this word, you'll probably see it in the homework somewhere, extraneous. When we do problems like this, and we are using factoring or quadratic formula, a lot of times you will get 2 answers, but a lot of times one of those answers actually doesn't work. So we have to check. So I'm going to plug in 4 into x in the original equation, and I'm just going to evaluate. I'm not going to do any math work. So when we plug in x equals 4, we ask ourselves, is 4 equal to the square root of 4 plus 12? 4 plus 12 is 16, and when we take the square root of it, we do get 4. So that does work. 4 does check. 4 is a solution. It works. When we plug in -3, we're asking, does -3 equal -3 plus 12? Excuse me, the square root of -3 plus 12. -3 plus 12 is 9. And the square root of 9 is 3. Please notice here, -3 and 3 are not the same. -3 does not work. So we got 2 answers from our work, but only one of them is actually a solution. Please make sure to check. Lots of times, only one will work. Sometimes both work. So I'm not saying it can only be one. Sometimes both will work. You should just check to see if it does. All right, I'm going to run through another one. If you feel comfortable with what you just saw, you can try this one on your own. If not, you can follow along with me. Step 1, isolate the square roots. This square root right there is by itself. So we move on to step 2, which is square both sides. We get x squared equals 2x plus 3. We're going to move everything to one side because we're solving a quadratic equation. We're going to subtract 2x and 3 from both sides. X squared minus 2x minus 3 equals 0. Those are some small numbers. That's something I want to try to factor, see if it's factorable. Not everything is, but I'm going to try. I'm hoping I can find 2 numbers that multiply to -3, and when you add them, we get -2. Those numbers happen to be -3 and 1. -3 times 1 is -3. -3 plus 1 is -2. Remember that those are the numbers we factor with, not the solutions. You have to take each factor, set it equal to 0, and you solve. And it looks like our answer possibilities are 3 and -1. But you know and I know we have to check both of them. So I'm going to take 3, I'm going to plug it in to the original equation, and I'm just going to evaluate. I'm not going to do any extra math. I'm just going to simplify the numbers. So is 3 equal to the square root of 2 times 3 plus 3? Well, 2 times 3 is 6, plus 3 is 9. And when we take the square root of 9, we do get 3. So 3 checks. And we're going to look at negative 1. We're going to ask ourselves, is negative 1 equal to 2 times negative 1 plus 3? 2 times negative 1 is negative 2 plus 3 is 1. And then we're asking ourselves, is negative 1 equal to the square root of 1? Unfortunately, in this case, when we take that square root of 1, since the square root is already on our paper, we only get positive 1, so that one does not check. So our only answer for this one is 3. Okay, the last problem that I'm going to do with you, and then I'm going to put the answers to the last two on the next page. I'm not going to talk about the extension. These are the ones just like yesterday where you have to be careful. Because we look at our square root, it's isolated. The square root on our last problem is isolated. So we move on to our next step, which is squaring both sides. But please look at that 2a on the left-hand side. Remember, when we square, we're squaring sides, not just the variable. So we're really doing 2a squared. And remember, 2a squared is 2a times 2a, which is 4a squared. Just like yesterday, be careful when you're squaring both sides. That number that's in front of things, sometimes you do have to square it. Just be careful with that. Now, while this thing is factorable, sorry, I gotta move things to the other side first. While this thing is factorable, I'm guessing a lot of you are going to look at this and say, oh, I didn't like factoring when the number in front wasn't 1. So for this one, we're going to use, or I'm going to use quadratic formula just to show you that, like, sometimes if you can't figure out how to factor it, or if you just don't want to factor it and you want to do it the long way, you can use quadratic formula. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Plug in all my numbers. And I'm going to start simplifying. The opposite of 8 is negative 8. 8 squared is 64. Negative 4 times negative 5 is positive 80. Oh, at the bottom, I almost didn't simplify. 2 times 4 is 8. 64 plus 80 is 144. And if you were to type that in your calculator, or you know your perfect squares list, the square root of 144 is 12. So this makes it a little bit easier to simplify here. And I'm running out of space. Negative 8 plus 12 divided by 8, that's 4 over 8, that's 1/2. Negative 8 minus 12 over 8, that's negative 20 over 8, that's negative 2.5. Now, since I am out of space, here's what I'm going to do. When you plug these back in to check if they work, you're going to find that 1/2 does work. You're going to find that that negative 2.5 does not. You might notice that a lot of times the negative answer is the one that doesn't work. That is true a lot of the time, but it's not true 100% of the time. So if you're guessing, yeah, you can pick the positive one. But I would not recommend guessing. I would recommend checking, because every so often the negative answer does work. So just be careful about that. So after this, you can work on your homework, try out these problems on MathXL. If you want to try the two in the notes on the next page, this is the last page that we would have covered in class, because the page after this is extension. I'm going to give you the answers. So if you want to try it yourself, you can figure it out, and I will be posting the completed notes at some point later today. Number 15, it actually has two answers, 8 and 4, and then number 16. When you solve it, you get y equals 2 and negative 3/4, or negative 0.75, but you'll find out that negative 3/4 doesn't work, and the answer is just 2. So have a great day. I'll see everybody tomorrow, and we'll talk a little bit about this stuff on Friday.